Hey, Julia, let me know when you're there.
Hi, Matthew.
Hey, Julia. So we left off here on previous problem here with, oh, I didn't even snip it in. There it is here. All right. What is the amount of drug at a maximum? So remember when the graph said to identify all the peaks and valleys and stuff like that? We actually already have that information, but we have to now interpret it. So there's 2 points. And if you remember, the first one is time in hours.
Mhm.
And the second one is the amount in milligrams, okay? Amount of the drug in milligrams, okay? So what is the amount of the drug at a maximum? So that's where we give that number that we just found from the graph, the 459.85 milligrams, okay? That's just straight from the graph. There's no real work to do there. Let me know when we can move on to the interval here.
Okay.
All right, so what interval is the amount of drug in the bloodstream increased? So you've seen this type of problem before. Increasing means it's going up and to the right. Okay. Now, if we go back and look at the graph, it looks like it's going up and to the right all the way over here. But remember, you can only start at 0. You have to say, well, only in this interval that it's actually valid for. There's no such thing as negative time in this problem.
Mhm.
It's start taking it. So it's increasing when it's going up and to the right. And very important here is that you're only increasing refers to the X values. Okay, so we only care about the X values. You don't care about the Y. So you just look, okay, well, it's increasing all the way up to here. What is the X value here? It's 6.25. It's increasing from 0 to 6.25. It does not include the endpoints. Okay, and the reason is at the endpoints, it's neither increasing nor decreasing.
Mhm.
All right, so that is everything for that question. Is there a part C to that?
The next part is where is it decreasing?
Okay, so decreasing. So it's decreasing when it's going down and to the right. Down and to the right. So, well, that's everywhere over here. It's decreasing all the way over here. It's going down and to the right everywhere over here. Even where it's still flattening out, it's still going down and to the right. So
Mhm.
that's 6.25 to infinity.
Okay.
Okay, that's it. For that. Maybe that was in another email here. Okay, so we're up to question 4 now. Does that look right to you?
Yes.
All right, so linear functions. This one's a submit a file. Okay, according to the US Census Bureau, the population in the state of Virginia was this people in the year 2010. In the year 2020, it was 8,600,000 more people. Lots of people, okay? Use this information to express the population as a linear function of time since the year 2010. So whenever you see something that says since the year 2010, that's now considered your base year. Okay, that's t equals 0.
Mhm.
Okay, and the reason they do that is to make the numbers more manageable, because when you multiply by years, you're multiplying by a 4-digit number. The numbers get really, really big, really, really quickly. Okay, and it's bad. It just gets bad. So this is kind of like what we're working on in the first 2 example problems. You need to come up with, well, what is the input? What is the output? And it's either time to population to time. What do you say here?
Time to population.
Yes. And that's how you, and then you like, I used to write this because I really wanted to make sure I didn't mess it up when I wrote the ordered pairs. You put time and then the population, time, comma, population.
Okay.
So you have to come up with 2 ordered pairs from this. So 2010 is year 0, 2020 is year 10.
Okay.
So could you give me the 2 ordered pairs whenever you have them?
The first one is 0, 8,001,024.
They're good.
And then the second one is 10, 8,600,000.
So like in terms of like how you'll start answering this question, like you want to first indicate, maybe even say like the input is time, the comma, like that, the output, because it says function, it's population, you want to write f of t.
Okay.
Right, and then we want to give those 2 ordered pairs. You write 0, comma, and I know it's a lot of writing or typing, but it's fortunately it's necessary. 0, comma 8, like that, and then the other one is 10, comma 631, 393, like that.
Mhm.
All right, and so the next thing is to determine the slope. The slope is the second value there, 8,631,393 minus 8 million, like that, over 10 minus 0. All right, so go ahead and calculate that. I'm going to do the same. I make sure the numbers do matter. So let's make sure we get them right. 8, 6, 3, 1. Did I miss a 0? No. Let me know what you come up with.
I got 62,036.9.
You got it. Yep. Okay. So that is the slope. And so your function here, I know it's a little bit different. So, but it's f of t equals your slope times t plus b. Like think of it as y equals mx plus b, like that. but we're
Mhm.
using t and f of t. T because of time, f of t is pretty standard there. So what we have so far is that f of t equals 63,036.9 t plus 9.
Okay.
All right. And then from here, we actually have the sorry, not plus 9, plus b. Oops. Brains malfunctioning. We do have the b value. The b value comes from the first ordered pair because it's 0 there.
Mhm.
You remember that from earlier?
Yeah.
And if it's not, if you don't like that, well, you put 0 in and this whole thing goes away and that becomes your b value. So it becomes, so you have f of t equals 63036.9 times t plus 8,000,001,024, like that.
Okay.
So that's your answer. I mean, that's everything for part. Well, that's everything for part A.
Okay.
Part B. Snip that in. What does this model predict that the population will be in the year 2033? So that's where you've got to say, okay, when it was 2010, time is 0. And when it was 2020, time was 10. So 2033 corresponds to what value of t? That's my question for you. Something to think about.
Is it 23?
23. Good. Okay. So when you're using this function here, you need a t value, and you don't want to put the year in because the year is not the input. The year is time. So it's f of 23 is 63,036.9 times 23 plus 8,001,024.
Okay.
And then you have to multiply this out. So you have to go to a calculator, get that number. I'll do the same and we'll compare results here.
I got $9,450,872.7.
And so this is another potential question for your teacher. If you want to be that like A+ 100% student, you would go and ask like, well, I know you can't have part of a human of your population, but that's what the model says. So do you go with like what the model says, or do you go with like, well, I need to round the result?
Okay.
Yeah, so go ahead and get that down, I guess. We'll move on to 5 whenever you're ready.
I'm ready.
Okay. Math instructor wants to exercise in the year by cycling. The cost to buy an exercise bike for her house is $23,018. So that's a one-time cost. One time you spend that amount. The cost to buy a membership, which has a one-time fee. I don't know if you've got a gym membership anywhere, but usually got to pay a fee plus a monthly card. Pretty kind of standard. A lot of the subscriptions now you don't have that one-time fee, but gyms still do that for whatever reason. And then the monthly cost to stream classes to the exercise bike for house is $39. So that's in addition to this bike. It's like you buy the bike, but you also want to buy the classes. I actually don't know if Peloton is that way or not, but I mean that's kind of the idea. You buy a bike, you still want to do the classes from home like that. Okay, so part A here is to create some functions here. So basically we got to create a function for the two options, like, and you'll do this the rest of your life. It's like option 1 is this, option 2 is this, option 3, or, maybe even option 3, but the total cost function for the exercise bike. So if you want to buy the bike, okay, you're going to pay $2,318 plus the $39 per month. Okay, so you might write it this way: C parentheses M cost per month is 2,318 plus 39 M.
Okay.
And you do want to say M is the number of months. Okay, number of months. And C of M is the total cost in dollars. And you should be seeing a trend here. I mean, typically time is the input, dollars is the output.
Okay.
Will you try writing the cost function for the studio for us, please?
Is it 50 plus 120 M?
Okay. Now there's a little more to part A that I'm not seeing here. Maybe that is it. That looks like it. Is that the bottom of part A down here?
Yeah.
Okay. So you either like, you need to somehow indicate that one is for the exercise bike and the other one's for the cycling studio.
Okay.
So either put those words next to it or, one level below, but you got to make that clear. And then part B, which I was figuring that's what I was going to ask you, is to graph. it's got a couple of parts to it. So let me know when you're ready for us to do part B.
Okay.
All right. So in part B here, you have to graph it. Now you can't graph it in this form because Desmos doesn't do that. Same with the TI-83. So you have to graph y equals 2318 plus 39x, y equals 50 plus 120x.
Okay.
Okay. Now we got to go and graph this. So I'm going to go to Desmos and graph this. And the hardest part about doing this, and I would recommend you do this on your own, either, after the lesson or, some point, is figuring out the right window. So the first one, and not to scale, the first one is going to start much higher and go up. The second one starts much slower, but goes up much, much faster. So you basically
Mhm.
want to box in. I'll just kind of do that in blue here. Like you're trying to get this sort of area here of it when you graph it. And I'm going to do that here as well for us. But that, like, the point is you got to be, you don't know where it is yet. So you have to just sort of like figure out where kind of everything looks okay. And let me do that here as well. So, all right. Okay. So first, a few things again, like you don't want to put this part in there. It starts at 0. This other one starts at 0, like that. And they do go on forever because you may own them forever, although no one lives forever. You know what I mean? There's always a
Yeah.
few. Uh, so you need to include that this is on the x-axis is the months, number of months. On the y-axis is the cost. And only include kind of this positive. Make sure you include some gridded, kind of these lines, major lines on there.
Okay.
So there's one more little part to part B once you get the graph down. So let me know. Always I'll send this to you at the end. But let me know if you want us to go to next part of that yet.
We can go to the next part.
Okay, so it comes from the intersection, and you do want to label the intersection on the graph there. You might even you might want, here's the other thing, I guess you might want to say that this one is the exercise bike. Yeah, exercise bike. And the gym cycling class, well, cycling studio. You do maybe want to label them as well so that you know which one is which. So but get back to your question here at the end here. They're asking you, how many months would you need to use the exercise bike in order for the total cost to match the total cost of the cycling studio? I mean, this is like a legitimate thing. I mean, people think, oh, I'm going to buy an exercise bike, I'm going to use it every day, or I'm going to go to gym membership, I'm going to go every month. I mean, it's kind of out there. You got a higher initial cost on the bike, but it's cheaper in the long run because you're not paying that gym membership as much for gym membership. But in the short run, it's better to have the gym membership. So that's why gym memberships are so popular, because people get them and then they don't use. How many months would you need to use the exercise bike in order for the total cost to match the total cost of the cycling studio? And it's 28 months. Yeah, 28 months.
Mhm.
How do you know? that is the intersection of the two lines.
Okay.
So I think that's everything on the assignment, but please double check. Yeah, that it's bad to miss a part, you got to really make sure you know everything that they're looking for. Like I said, everything's kind of more, it's like everything it matters now. There's no flexibility. Yeah, they don't care if it's late, they don't care if you forgot to upload a file, they just,
Yeah.
you know, too bad, so sad, which it doesn't sound very nice, but that is what they do. So
Oh, there was a part when we did question 2, the test market data, there was a
okay.
second part where it's does the table indicate that demand is a function of purchase price? And then why or why not?
So I kept saying it was the same, it's the same reasoning each time, which I don't really like, but it's the same for every input, there is unique output.
Okay.
And it's because like 10 goes to 8,000 and there's no duplicates here in the X. Like imagine 10 going to 8,000 and 10 going to 7,500. That's bad. That means there's an unknown there, and that does not pass the vertical line, or does pass the vertical line test. So you have to, I think you have to look at your notes, maybe have a quick email with your teacher. I don't know. Are they using Teams, Microsoft Teams in this class at all?
Is it what?
Teams, Microsoft Teams. They were using that last year for summer.
No, I haven't heard of that.
Okay. I would communicate and say, is this okay? Or do I need to be more specific and say, like, for every purchase price, there is a unique demand. For every demand, there is a unique purchase price.
Okay.
I guess I'll type that here. So that's for the first one. And then for the other one is for every purchase price, there is a demand. Demand for every unique purchase price, there is a demand. Did I say that? Sorry, the other way. For every unique purchase price, there is a single demand. So I mean, I think I'm getting too like picky here. just keep double checking, make sure you got all the questions answered. You feel like it's fully answered.
I would say so.
Okay, great. All right, where should we go from here?
Is there another example?
There's several. There was one from like you sent up several in the emails. So you just have to kind of tell me which one you want us to go through next, and I'll do my best here to answer it.
Maybe if we could do another example on graphs of functions.
Okay. You know which email or any like word to go along with that for me to look for?
Let's see. I think the second email I sent you, there's one at the very bottom and it says like a business has determined a mathematical model based on the market data of its profit.
Okay, yeah, let's look at that. Good. Okay, a business has determined a mathematical model and based on market data. What is meant by profit? How does it differ from other related terms like revenue and cost? Okay, so this one is where again, if you're going into business, like this is key. Revenues are the money you take in.
Okay.
So you bought a lesson from me. So when you buy the lesson, that's a revenue. Okay. There's,
Okay.
she paid for lesson, that's a revenue. But the costs are money that goes out. So when you buy a lesson, and this isn't like this is reality, there's fees, PayPal takes a fee, the scheduling software takes a fee, there's fee for the internet, there's electricity, there's fees, there's costs. So you don't get to keep all the money. Okay. But usually your revenues exceed your costs. So your profit is your revenue minus your cost.
Okay.
So your revenue is what you take in. Usually there's a function they give you or an equation, and the cost is whatever's going out. And this function right here is giving you the net result of that. They're saying the net result is after revenue minus cost is this. Now, normally they give you a revenue function and a cost function and you subtract.
Okay.
So that's everything for number one there. All right, so graph this function in your graphing calculator in an appropriate viewing window. Trying to remember, I don't think you do a ton of graphing in college algebra on tests. I think they do. I don't want to say this, like they don't really give you graph questions because they're too easy. You just graph them and you're done. So I guess I'll just graph this one. in the other window and snip it in, but you should go to Desmos and try graphing these on your own. Or on your graphing calculator. You will be doing more graphing if you're taking, even if it's just a few math classes, you're going to have to do some amount of graphing. And the hardest thing is getting the windows. Like that's what students struggle with. All right, so I've got a window here to show you. So this problem talks about the number of items sold. So can you sell negative items? Is my question to you. Like, is this part of the graph reasonable over here?
No.
No, you can't sell negative items. You can't sell. You can't have negative. Well, that's not true. Sorry. So if you take an economics class, you can have negative profit, which is, I don't know why you would do that, but sometimes there's situations, but you definitely can't have negative items. So it would start here, goes up and comes back down. Okay. Now, quadratics, as you know, because you've studied these for years now, there's a couple of places of interest. Usually there's the vertex that you care about. Okay. But in profit problems, sometimes you care about the intercepts. Okay. So let's see what this one's asking for. I don't really know because I didn't read it. I didn't look ahead yet. All right. So 2 and 3, they kind of go to my point of like, you need to get comfortable graphing this stuff. Okay. And to graph it, you need to know what things will be helpful in determining an appropriate viewing window. So what I generally do is I look at the X and go out by zeros. So I'll do like 10, 100, 1,000, 10,000. And 10,000 is way out here. And if you want me to show you this, I can. I'm happy to do that. If you think that would help, just let me know. On the Y, it's the same deal. You just go up by like 0, 10, 100,000, and hopefully you start to see it, and then you kind of zoom it in, condense it.
Okay.
All right. So that's all I can say on that. What is the natural restriction on X? Okay, we actually already talked about that. So the natural restriction on X is that you cannot sell negative items, negative number of items. So X has to be greater than 0. Like,
Okay.
okay. So for the next part here, for number 5, I'm going to ask you to get involved here. It wants you to determine P of 50, And you have the function. The function is given. Function is given here. So they're asking you to put 50 in for X. So go ahead and calculate that for us, please.
$63.50.
Okay. So we can check that on the graph. So if you have the Desmos, you can sort of roughly figure out if that's kind of right. And what that represents. Well, actually, did you mean negative? So there's an issue with this. This is not the right number. I'm sorry. I'm gonna try that one more time.
Oh, wait, is it 5850?
It is negative 6750. Let me know if you need me to show you that. The calculator. It is really important that you can get this value because you'll be doing that a lot in this course. They'll give you a function, you'll have to put a number in.
Can you explain how you got that? Because I keep getting 5850.
All right. Let's just go through it piece by piece here. Are you doing it all at once or just kind of piece by piece?
I try to do it piece by piece.
Okay. So 50 squared is 2,500. All right, and then it's negative 0.1 times that. That's going to be negative 250. 150 times 50 is 7,500. And then you're subtracting 14,000. And then you'll see that that does give you this. Now, you really do want to get to the point where you can do this all in your calculator. So you've seen me for years show you that you do, like, the way I write it is the way you enter it in the calculator.
Yeah.
And if you take just a little bit of time to work on that, you'll gain from doing it that way, because it's better to do it all at once than to do it in pieces. Plus it's slower. You'll find that you don't have as much time in the classes as you think to do problems.
Yeah.
Okay, now that we got the right number, it's like, what does this tell you in practical terms? So I'm actually going to snip the graph in again because that it's like it's important to see it visually. It's like, well, what is that? Well, it's not a good place to be. Your profit is negative.
Mhm.
Now, if you and I opened a business and we had negative profit, that's not a good thing. But if we knew it was trending to where we could get positive profit or maximize our profit, we might keep it open.
Mhm.
But because it's negative, that's not good. Um, you know, a lot of businesses that are really just hobbies end up failing because they just don't make a profit.
Oh.
So when investors come and they want to, they're looking at a business to buy, they always ask for your profit. What's your profit? What's your gross revenues? Because they want to know. They want to know how much money you're making. They want to know if it's worth putting their money into.
Okay.
All right, then we got this last part here. All right, so it says use the graph to determine the number of items that should be produced and sold in order to maximize profit. So again, we're going back to the graph again, and it's the peak. It's the vertex. It's the place where your highest value. And businesses do try to achieve this. You want to you want to make as much money as you can. And in this case, if you sell 750 units, your profit is this other number.
Okay.
All right. Did we accomplish everything you wanted to do today?
Yes.
Excellent. All right. I'm going to go ahead and stop here for today.